Okay, so in this example, we're going to take a look at the elimination method. All right, and here we have a system of nonlinear equations. In this case, both of these equations are nonlinear. What we have is the first one representing an ellipse and the second equation representing a circle. If we look at the graph here, right, we can see that we have 4 points of intersection. So the solution of this equation will have 4 coordinate pairs, right? 4 solutions. Now, the term elimination, right, comes from multiplying some factor to 1 or 2 of the equations, and then when you add them, you eliminate a variable, right? Hence the name elimination. So here I don't need to multiply by anything. I notice that both of the y squareds have a coefficient of 1. So what I'll do is I'll just subtract one equation from the other. Right, so what we have here, I can think 4x squared minus 1x squared leaves me 3x squared. Here we have minus y squared plus y squared is 0, right? What I wanted to eliminate one of the variables. And here we have 13 minus 10 gives me 3. Right, and then dividing, now I can solve this basic equation in one variable. Dividing through by 3, we get x squared equals to 1. Okay. And now taking the root. All right, again, always when we take the square root of a square, don't forget the plus minus. All right, the square root of x squared is plus or minus 1. Okay. All right, so now I found the x coordinates. So now let's go ahead and find the y coordinates, right? So let's see what happens when x is equal to 1. Okay, so here it doesn't matter which one you choose to plug it in, right? So here I'll go ahead and just choose 1, or excuse me, the second one, x squared plus y. It just looks a little simpler, right? So I'll plug in 1 for x and go ahead and solve for y. So we get 1 plus y squared equals to 10. Subtract 1 from both sides. We get y is equal to 9. All right, and then here we take our square root. And again, always when taking the square root, take plus or minus. So the result of 1 gives me 2 y coordinates. So this leads to 2 solutions, 1 comma 3, 1 comma negative 3. Right, and we can see that in our graph, right? When x is 1, and we see our solution here, and we see our solution down there. All right, so we found both those. All right, and now we can see in a similar note here, when x is equal to negative 1, we notice the square actually, plugging it in here, when I square it, I get back essentially the same equation. 1 plus y squared equals to 10. Subtract 1, we get y squared is equal to 9. Take the square root, again, plus minus, y equals to plus or minus 3. So this gives me 2 more solutions, and the rest of the solutions, negative 1, minus 3. Right, so negative 1, right, for each one of these. Excuse me. And you see here, we get the rest of those solutions. We have 4 solutions that we found using our elimination method.